Differential Calculus 2. We're going to start looking at functions of two variables or three-dimensional functions. Up until now you've looked at functions like y equals mx plus c. We've only had x and y, so feature first now would be done on a plane. We're now going to move and have a look at things which have two different variables, x and y, and z is going to be the third variable. So we could have things like z equals x squared plus y squared. Some function of x and y that gives z, which enables us to look at things in three dimensions. So just to get a handle on what's going on, let's start with something nice and simple. So if we've got just a closed cylinder, and we'll say that it's got a height h, that's one variable, and a radius r, which is going to be a second variable, and then we can define things with regards to those two variables. So for example, the volume will be pi r squared h, and the surface area of it, if it's closed, we'll have two lots of pi r h, which will be the around the side, so 2 pi r is the circumference times h, so that's the outside of it, plus the top and the bottom, so that's two lots of pi r squared. Okay, so we have functions for the volume and for the area, each of which have two variables in them, r and h. And what we're going to want to do now is start asking the question, what happens if one or the other of the r and the h changes while the other stays constant?